In this video, we will discuss the principal conservation of momentum. So here we will see how conservation of momentum works and what is the meaning of the conservation of momentum. So first of all, the principle says that if no external forces act on a system of colliding objects, the total momentum of the objects in a given direction before collision equals to the total momentum in the same direction after collision. So it says that the total momentum before collision will be equals to the total momentum after collision. This is known as the principle of conservation of momentum. So let us see how it works. Suppose this is an object and the mass of this object is m1 and it has an initial velocity of u1, and this is also an object and this object has a mass of m2 and the initial velocities of this object is u2, and this is the scenario before collision. So both of them are moving in the same direction. If u1 is greater than u2, then after some time t second, this m1 object will collide with the m2 object. This is the collision moment. And when this collision occurred, what will happen after collision? After collision, this m1 object will now have a velocity which will be the final velocity of v1, and the m2 object will have the velocity of v2, and both will be in the same direction, but in that case v2 will be greater than v1. So this is the scenario. If we apply Newton's third law, then we know every object has an equal and opposite reaction. So if it enforces F1 force, then this M2 object will be enforced an F2 force within the opposite direction. And we know that by the help of Newton's third law, we can say that F1 will be equals to F2, but they are opposite. So we will have to use a minus sign. So what is F? We know for F, F equals to ma. Force means mass into acceleration. So in that case, for F1 we'll have F1 equals to m1 a1, and for F2 we'll have m2 a2. And what is A? We know A is acceleration is the rate of change of momentum. So we know acceleration is v minus u divided by t. So in that case, for a1 we can write m1 into v1 minus u1 by t, and for a2 we can write v2 minus u2 divided by t. So if we solve this equation, if we cancel t from the both sides, then we will have m1 v1 minus m1 u1 equals to minus of m2 v2 minus plus m2 u2. So if we rearrange this whole equation, we'll have m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So what is this m1 u1 plus m2 u2? m1 u1 is the and m2 u2 is the total momentum before collision. Total momentum before collision. And what is m1 v1 plus m2 v2? The m1 v1 and m2 v2 means the total momentum after collision. So this is the principle that we prove from by the help of Newton's third law. So if we have to apply the conservation of momentum, we will have to use this formula for solve mathematical problem. So this is known as conservation of momentum. Now we'll see some example of conservation of momentum. First of all, we'll see an example of recoil of a gun. The first example is recoil of a gun. Here, suppose this is a gun and we will fire a bullet from this gun. When the no bullet is firing from this gun, suppose we take that the mass of the gun is m of g equals m of g and the initial velocity of the gun is u of g, capital U of g, and s, when we don't shoot any gun from this when we don't shoot any bullet from this gun, the initial velocity of the gun will be 0. And suppose the mass of this bullet is m of b and the initial velocity of the bullet is ub, and when we don't shoot any any bullet from this gun, the initial velocity of the bullet will be 0 meter per second. This is the representation of gun and the initial velocity before firing a bullet. When we fire a bullet, before this is the before firing bullet. So when we fire a bullet at the velocity of v of b, then we will see, suppose we have to find out what will be the final velocity of the gun, that is capital V of g. So what will be the final velocity of the gun when a bullet is fired from the gun with the velocity of v of b. So we know, by the help of the conservation of momentum law, we know m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. That means the total momentum before collision equals to the total momentum after collision. So here collision means firing the bullet. For m1 we will use m of g, and for u1 we will use u of g. For m2 we will use small m of b, and for u2 we will use small u of b. For m1 we will use m of g v of g, plus for m2 we will use small m of b, and for v2 we know this is the v of b. As the initial velocity both gun and bullet is 0, so this will be 0 and this will be 0, then the whole term in the left hand side will be 0. So if we find out the velocity, the final velocity after firing a bullet for this gun, then the v of g will be m of b divided by into v of b divided by m of g, and it will be in negative sign. So what is the negative sign means? What is this negative sign means? If we fire a bullet in that side, the gun will be moved in the left side with the velocity of v of g. That's why when we fire a bullet from a gun, the gun will come backwards and gives us a force towards our shoulder. This is the recoil of a gun. That's why when we shoot a bullet from a gun, we have to maintain a connection of this section with our shoulder. So this is an example of conservation of momentum of recoil of a gun. Then let us take another example of conservation of momentum. Suppose this is an object m1 and this is an object m2. and they both come from the opposite direction. So as we know, velocity is a vector quantity. If the m1 object is moving with the velocity of u1 and m2 object is moving with the velocity of u2, then if we take u1 is positive, if we will take u1 as positive, then u2 will be negative because they are opposite. Vice versa, if we take u1 is negative, then the u2 will be positive. Means if we take the initial velocity for m1 is positive, then as they are coming from opposite direction, so u2 or the initial velocity for the m2 object will be negative. So suppose we take u1 as positive and u2 as negative. So when it collide, this is the before collision and this is the collision occurred, and when the collision is occurred, suppose both the object is moving with the same velocity at some direction, so it can move in that direction also with same velocity, and it will interact with one another after collision, or it will be go in the right direction. It can be go in the left direction, in the right direction. We will find out where will be the our final velocity will be occurred based on the value of our final velocity. So we know for the formula of conservation of momentum is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. What that means, the total momentum before collision equals to the total momentum after collision. Here we can see that u2 is negative and u1 is positive, so we can write this thing as m1 u1 minus m2 u2, and as we see that the both object will be moved together with the same velocity as v, so we can, for v1 and v2, we can replace this v1 and v2 as v, and if we take common v, then we will get m1 plus m2. So we can write the final velocity v is m1 u1 minus m2 u2 divided by m1 plus m2. So if the result of v is positive, if the result of the v is positive, then the both object will be go in the right direction, as the positive direction is in the right side. And if the value of this v is minus, then they both will be moved with the velocity of v in the left direction. So by the help of this plus and minus sign, we will find out where the both object will be go, and the v, the value will be give us in what velocity both the object will be moved. So this is the whole concept of conservation of momentum. I hope you understand this concept of conservation of momentum. We'll solve some problem on this principle of conservation of momentum, and we will get a clear view of how this conservation of momentum works in our day-to-day life. Like another example of conservation of momentum is like jumping from a boat. Please try to find out how conservation of momentum is work in this jumping from a boat. There is several examples. We can take several examples. This is one kind of example for understanding the conservation of momentum. There are several examples. So try to understand how jumping from a boat is worked on the conservation of momentum. I hope you love this video. Please like this video and subscribe to our channel. Thank you.